Hi, let's now look at another example under integral calculus. This is also an indefinite integral. You can check out the other question that we did. Check out the link in the description below. Yeah. So what we are going to do right here is that there are two ways to go about this. There's a way that can save your time. Okay. There's a way that can save your time. And there's a way that can waste your time. So let me show you a part of how to waste your time when solving this question. Okay, so what it is here is that I can choose to say, okay, considering the fact that I'm talking about this is a product of two functions. You have an exponential function that is raised to an algebraic function. Then you also have a trig function where the angle is an algebraic function. Okay, so now what happens here is that I can just say, okay, I can use integration by parts. Okay, we know integration by parts is simply u dv. It's written as the integral of u dv equals to uv minus integral of v du. Okay, so I can choose say, okay, I can choose to let my u be equals to the exponential function, which is e to the power x, then my dv to be equals to the exponential function, which is sec squared e to the x, like that. Okay, so meaning my du will still be the same. Okay, so it's like it will be e to the x multiplied by the derivative of the power. The derivative of the power is a 1, so it will just be like that, and I'll say dx there, like that. Okay, then for my v, it's just the integral of this one. Okay, so when you integrate this one, this will simply be something like that would be tan e to the x. I still maintain the same angle, then I divide by the derivative of the angle. Okay, the derivative of the angle is e to the what? E to the x. So when you get to integration by parts, u by v, like this u by this v right here, what you're going to end up with is something like that, is like tan e to the x, then you're going to say minus v du. Okay, so that is this one multiplied by that one, and what you end up with is the integral of tan e to the x dx. It's simply because this one will cancel out with this one right here. So you can actually go ahead and continue integrating this, but I'm going to show you a way in which you can save a lot of time. It can't even take you more than 30 seconds, I think, if you are very fast. You're just going to use U-substitution, where you're going to say your u, let your u be equals to e to the x. That u that I'm picking is this one here, not this one. Okay, so meaning you can come up with your du will be equals to e to the x dx. So you can say your dx is equals to du divided by e to the x. So you come here and say you have your e to the x multiplied by sec squared u here. Instead of dx, I'll put du divided by e to the x, whereby this can cancel and that one can cancel. So you just remain with the integral of sec squared u du. To integrate this one, it will just be tan u plus what? Plus the constant of integration. So this will be like tan, what is our u? Our u is e to the x plus c, and this is our answer. That's how you can save your time instead of using integration by parts, and that's how you answer that one. Thank you very much for watching.